Hello students, today in this video we'll see about the double fertilization. In last video we have already studied pollination. Today we are going to complete double fertilization and post fertilization changes. What is double fertilization? First we will see the fertilization. In fertilization, fusion of two gametes takes place, that is male and female gametes fuse to form diploid zygote, and zygote then used as the formation of embryo. It is fertilization. What is double fertilization? In double fertilization, both the male gametes which are produced, they take part in the fusion. One fuses with the male gamete, other fuses with the secondary nucleus or polar nuclei, and this fusion takes place at two different places, and that's why it is called as double fertilization. Double fertilization is a unique process of the angiospermic plant. It is important characteristic of the angiosperms, double fertilization. This double fertilization was first studied by Navas-Chim in the plants Lilium and Fritillaria. We will see the entire process of the double fertilization. The process of double fertilization starts from the pollination and ends up to formation of zygote and primary endosperm nucleus. Whole or the entire process, it can be divided into four distinct stages or stages. The first stage is siphonogamy. What is siphonogamy? Siphonogamy is the transfer of the non-motile male gametes with the help of pollen tubes towards the female gamete is called as siphonogamy. As the male gametes are non-motile, they have to be transferred towards the female gamete, and these male gametes, they are transferred with the help of pollen tube. After pollination, what happens? The compatible pollen grains absorb the different chemical substances at the tip of stigma. Intine grows up, enters into the stigmatic tissue. It goes deep down into the stylar tissue. The content of the pollen grain, that is cytoplasm along with the vegetative nucleus and generative nucleus, they travel or migrate into the pollen tube, and the pollen tube grows towards the basal ovule. This growth is controlled by the chemicals present in the synergies. Okay. During the traveling, generative nucleus divides and forms two male gametes, and these two male gametes are carried towards the female gamete with the help of pollen tube, and this process is called as siphonogamy. First. Second step, that is porogamy. What is porogamy? When the pollen tube reaches to the ovule, it enters in the ovule through the micropyle which is present towards the funiculus. When the pollen tube enters in the micropyle and then into the embryo sac, it is called as porogamy. But there are another ways are also present. Sometimes pollen tube also enters into the ovule through the chalaza by crushing the chalazal end, and sometimes it also enters through the integuments. There are three ways. Porogamy, when pollen tube enters in the ovule through micropyle. Okay. Then chalazogamy, when pollen tube enters in the ovule through chalaza. And mesogamy, when pollen tube enters into the ovule by crushing the integuments. These are the three components, three phenomena by which the pollen tube enters into the ovule. Third process in the double fertilization is syngamy. What is syngamy? Syngamy is fusion of one male gamete and one female gamete to produce zygote or diploid zygote. The male gamete is haploid, female gamete is haploid, they fuse together and form a diploid zygote. It is called as syngamy. Syngamy produces diploid zygote. And last step in the process of double fertilization is the remaining male gamete fuses with the polar nuclei or secondary nucleus and forms a diploid primary endosperm nucleus, which is called as PEN. It is called as triple fusion. Why it is called as triple fusion? Because three nuclei come together, fuse together and form one nucleus, that is primary endosperm nucleus, and that's why it is called as triple fusion. Endosperm is the nutritive tissue which gives nutrition to the developing seed as well as during the germination. Here ends the process of double fertilization. Now the significance of double fertilization. Double fertilization is very important because zygote, diploid zygote is produced by the process of double fertilization. It is the product of double fertilization which gives us the formation of embryo. Embryo तयार होतो सगळ्यात महत्त्वाचा पहिला significance. Second significance of the double fertilization is it gives rise to formation of endosperm in the seed. Endosperm nutritive tissue, हा nutritive tissue seed मध्ये तयार होतो. It is only because of the second double fertilization. Double fertilization was फक्त endosperm निर्माण होऊ शकतो. Third significance is it triggers, it gives rise to formation of post-fertilization changes. Post-fertilization changes ना यावरून सुरुवात होते. म्हणजे formation of seed, formation of fruit, formation of embryo, formation of endosperm या सगळ्या गोष्टी fertilization झाल्यानंतरच complete होतात. Diploid condition is maintained in the next generation. यामुळं पुढच्या जनरेशन मध्ये diploid condition maintained. 4-5. These are the important significance of the double fertilization. Now, you will see a short video about the live video showing the double fertilization, and then we will continue the next part.
Fertilization event to occur, the male gamete, the sperm, must travel from the anther to the embryo sac within the female reproductive organ. The pollen grain contains two main cells. A cell named the tube cell makes up the bulk of the pollen grain, and the sperm cell, which at this stage is known as the generative cell. To reach the embryo sac, a pollen grain must land on the stigma. Once landed, it begins to germinate. The tube cell forms a long structure down the style and into the ovary. The generative cell travels behind the tube cell nucleus. Once near the ovary, it divides by mitosis to produce two haploid sperm cells. The pollen tube reaches the micropyle and releases the sperm cells into the embryo sac. One of the two sperm cells fertilizes the egg cell. This produces a diploid zygote, which will become the embryo. The other sperm cell moves up and fuses with both of the central nuclei, forming a triploid cell. This unusual triploid cell develops into an endosperm and serves as the embryo's food supply during early development. It is only angiosperms, flowering plants, which have this double fertilization characteristic, where a diploid zygote and a triploid endosperm form. Gymnosperms, pines, tracheophytes, ferns, and non-tracheophytes, mosses, lack this double fertilization feature.
Now, we will see the post-fertilization changes. What are post-fertilization changes? The changes taking place in the ovule, after fertilization, they are called as post-fertilization changes. They are of different ways. After fertilization, zygote is formed. The zygote grows into the embryo. The primary endosperm nucleus is gives rise to formation of endosperm. Entire ovule is converted into seed, and the ovary is converted into fruit. All these changes, they are concluded in the post-fertilization changes. All these post-fertilization changes, they are taking place simultaneously. When zygote is converted into embryo, at the same place, at the same time, PEN is going to form endosperm, seed formation also taking place, and fruit formation. They are simultaneous process, but we will study one by one all these things. First, we will see the formation of endosperm. Endosperm is the nuclear tissue. Endosperm is formed from the primary endosperm nucleus. The endosperm is formed by the division of primary endosperm nucleus, and there are three ways of formation of endosperm. Three types of the endosperms are seen. Development of the endosperms are seen. First is nuclear type of endosperm formation. In some plants, the primary endosperm nucleus, which is the product of double fertilization, it undergoes, where it is present? It is present in the embryo sac, in the cytoplasm of the embryo sac. This primary endosperm nucleus undergoes pre-nuclear division. Many mitotic divisions take place in that nucleus, and as a result of this, large number of nuclei are formed in that cytoplasm. First, all the nuclei are formed without cell wall formation. Cell wall formation होत नाही, फक्त न्यूक्लियस मध्ये असंख्य मायटोटिक डिव्हिजन्स होतात आणि असंख्य न्यूक्लियाय तयार होतात. Then all these nuclei, where they are present in the cytoplasm, in the embryo sac. Then they collect some of the cytoplasm and form cell wall around it. प्रत्येक न्यूक्लियसच्या मोठी cell wall तयार. And this formation of cell wall, it starts from periphery to the center. एम्ब्रियो सॅकच्या कडेपासून मध्यभागाकडे हे cell wall formation होते. In some states, central vacuole is produced. मध्य भागात vacuole सुद्धा तयार होतो. And the cellular endosperm is formed here. For example, the best example is coconut. नारळामध्ये मोठा एम्ब्रियो सॅक आहे, मध्यभागी व्हॅक्यूल असतो, पोकळी असते. सुरुवातीच्या काळामध्ये नारळामध्ये आपण पाहतो की त्यामध्ये फक्त शहाळ्यामध्ये फक्त पाणी असतं, त्यामध्ये खोबरं नसतं, बरोबर. त्या पाण्यामध्ये काय असतात? देर आर सो मेनी प्रायमरी एंडोस्पर्म न्यूक्लियसचे डिव्हिजन होऊन असंख्य न्यूक्लियाय तयार झालेले आहेत. आणि त्यानंतर जसजसं दिवस जातील तसं शहाळ्यामध्ये बाहेरून आतमध्ये काय तयार होऊ लागतं? आपण ज्याला मलई म्हणतो. मलई म्हणजे दॅट इज एंडोस्पर्म. हे कडेपासून मध्यभागाकडे तयार होतं आणि ज्यावेळेला हे संपून जातं, मध्यभागी मोठी पोकळी तयार होते, दॅट इज व्हॅक्यूल. आणि पाणी संपतं म्हणजे त्यामध्ये सर्व सायटोप्लाझम पासून मध्ये असणारे न्यूक्लियस पासून काय होतं? सेल्युलर एंडोस्पर्म तयार होतं. That is the best example of the nuclear endosperm. It takes place in the coconut, wheat, या plants मध्ये nuclear endosperm. Next one is cellular endosperm. In cellular endosperm, what happens? The primary endosperm nucleus, याच्यापासून endosperm तयार होणार. It divides by mitotic division, but after every division, cell wall formation takes place. प्रत्येक डिव्हिजन नंतर cell wall formation होते. एकदा सेल प्रायमरी एंडोस्पर्म न्यूक्लियस डिवाइड झाला, लगेच सेल वॉल तयार होतं, एकापासून 2 सेल्स तयार होतात. त्यानंतर 2चे 4 तयार होतील, 4चे 8 तयार होतील. या पद्धतीनं मायटोटिक डिव्हिजन असंख्य होतात. मात्र प्रत्येक मायटोटिक डिव्हिजन नंतर इमिडिएटली लगेचच सेल वॉल फॉर्मेशन होतं. त्यामुळं एंटायर सेल्युलर एंडोस्पर्म तयार होतं. एक्झाम्पल इज बाल्सम नावाचा प्लांट आहे, त्यामध्ये अशा प्रकारचा एंडोस्पर्म. थर्ड वन इज कॉल्ड एज हेलोबियल एंडोस्पर्म. Helobial endosperm formation is the hybrid of both nuclear and cellular endosperm formation. दोन्हीचं कॉम्बिनेशन असं आपण म्हणतो. यामध्ये काय होतं? फर्स्ट इन द एम्ब्रियो साइट, प्रायमरी एंडोस्पर्म न्यूक्लियस डिवाइड बाय सेल्युलर डिव्हिजन. म्हणजे पहिली फक्त डिव्हिजन काय होते? सेल्युलर डिव्हिजन होते. 2 न्यूक्लियाय तयार होतात, मध्ये सेल वॉल तयार होतात. त्यानंतर ते मात्र द न्यूक्लियाय विच आर प्रेझेंट इन बोथ दीज सेल्स दे अंडरगो प्री न्यूक्लियर डिव्हिजन. त्यामध्ये प्री न्यूक्लियर डिव्हिजन होते, म्हणजे असंख्य न्यूक्लियर तयार होतात, सेल वॉल तयार होत नाही, सेल्स तयार होत नाही. आणि एकदा न्यूक्लियर तयार झाल्यानंतर पुन्हा मग पेरिफेरी कडून मध्याकडे, म्हणजे कडेपासून मध्याकडे पुन्हा त्याच्यावरती सेल वॉल तयार होतो आणि त्यानंतर मग एंडोस्पर्म कंप्लीट होतो. इट इज कॉल्ड एज हेलोबियल टाइप ऑफ द एंडोस्पर्म. हेलोबियल या ऑर्डर मध्ये, या प्लांट्स मध्ये अशा प्रकारचा एंडोस्पर्म तयार होतो. दीज आर द 3 टाइप्स ऑफ द एंडोस्पर्म.